I've been going down quite a big rabbit hole recently in regards to end-fed half-wave transformers and their efficiency. So what we're looking at here as a 3-stack of FT240-43s and FT240-52s. They look absolutely the same to the eye, and you wouldn't know unless these were actually labelled up. So I've made some previous videos on this subject, so I'm happy with a core and a winding that I've got for a QRP version. We've got the 1002 core, which is, I think, you know, the best value core for 100 watts, and that's 100 watts digital modes, efficiency over 90%. And I'm glad to actually see that a lot of people are actually adopting that core instead of the standard FT240-43 in their end-fed half waves. But one thing remains, and that is QRO, or high power. And traditionally, a lot of people like to run a 3-stack of cores because they can actually run a lot more power. Now, depending on if they're using 43 material or 52, 52 has a Curie point, and the Curie point is basically at the point at which the material loses its properties, and that's the point that your SWR's going to rise. So the Curie point of 52 material is much higher than it is of 43. I can't remember those two temperatures, but I'll put them up on the screen as to what they are. So what you tend to find is people that want to say run a kilowatt or a kilowatt and a half of full duty cycles like CW, they'll tend to use the 52 material. But is that the most efficient? And I'm going to share some information with you here just now. As with the other FT240 transformers, people used to mostly, or historically, have used just that standard winding, you know, the wide space winding with the crossover. But I've done some experiments, as I've just said. These ones that we're looking at here are from my latest experiments, and this is actually what you call a auto transformer. So instead of having a twisted primary, you know how you start with twisting the wires, wrapping it round, we basically use a single wire, and then we just solder on, what we call is we tap it, and we solder a wire on. It's much the same. It's not really any more difficult than to wind a standard end-fed half wave. Just means you've got to basically scrape some solder off and before you solder on your tap. And I'm pleased to say that I think I've got an acceptable compromise for you guys that want to run high power. So without any further ado, let's go and take a look at the results. So I made a previous video using the 3-stack of FT240, 43s and 52s, and I have to hold my hand up here and say that I actually made a mistake. There was one set of results for 43 material and 52 that were wrong, and this actually came down to a setting on the Nano VNA. It was actually pointed out to me. I knew something wasn't right, and somebody rightly told me as well, so they didn't know exactly what I did wrong either. But it wasn't the calibration, but what it was on the Nano VNA, you can select channel 0 reflect or channel 1 through, and for some reason the Nano VNA was set to channel 0 reflect. So I think it's just because the power had been off for a length of time and it had reset itself. So the error in question was, let me just see, was this one here. So it was a 3-stack with closed spacing. That's the one, and it's actually come out to be substantially better than what it was before. So we'll just have a brief run through here. I'll show you a graph once we get to the end here. So the bog standard 3-stack, this is our efficiency here. This is the wide spaced with the crossover, and you can see we're 8 to 8, 8 to 8. It's pretty steady, even up to 15 it's pretty good. Once we get to 10 meters, you can see that we're losing quite a bit of efficiency there. When we actually do a close spaced, we actually improve things. And Evo Lair, he found this to be in the videos that I watched. So you can see that we're actually increased from the 8 to 8. We're up to over 90. 15 is much the same, but you can see that we've improved 10 meters somewhat. This is the same reading that I've just spoke about here, but without the capacitor. What you find is the capacitor actually makes the transformer much more efficient, so it's always better to have the capacitor in place. But if you actually look at the auto transformer, you can see that this is much better on both accounts, and that's what this is here. And if we look at this is the one that we actually want to look at here, the one on the end. This is without the the capacitor. But here you can see that I'm actually quite amazed that the results are actually as good as this. 160 through 15 meters, we're up at 90%, with the exception of 15, but it's marginally below 90%. Even if we look at 10 meters, we can see that we're still over 80%. So that, to this point, is actually the best I had seen. And then we actually need to have a look at the 240-52. Now the 240-52 has some different properties to it, and it behaves differently at different frequencies. So again, this was the original close space windings that I had the problem with the measurement before, and you could see on all of these that the 52 material is quite poor on 160 meters. Now you need to decide if 160 meters you need that or you don't. So that's a question you need to ask yourself. So that was the reading that I read. And again, I did the auto transformer then. So this is without the capacitor and this is with. And you could see that our efficiencies are actually, this is actually probably the best end-fed half-wave efficiencies I've actually seen for 80 through 10 meters, because what you tend to find is when you stack the cores, that's when your efficiency goes on 10 meters. It gets better at the bottom end, but poorer at the top end. But if you look what's happened here, we've got this 66% on 160, which I'm personally not interested about. And I've actually never seen results like this. And this is what we're actually looking at here. If I just find the right one. Yes, this is one here. This is the 52 material. So this is basically what you should perhaps try and see if you can actually get it to make a working antenna. And just for some reference, we've got the 1002 core here. So this was a 2-stack, and this was just wide spacing over it. And you can see that it fell away on 15 and 10, but still decent up to that point, up to 96 actually on 160. So maybe I need to try an auto transformer on that. So if we actually do a basic graph that I've done, and this is just the 240 size cores that I've been speaking about here, it puts things into a little bit more perspective. Efficiency up the side, we've got the band along the bottom. So you can actually see these two that are green here. These are both auto transformers, one being the 52, which is this, and this one being the 43 material. So personally, I'm not actually interested in 160 meters, so for me, you can take that out. And I'm not really interested in 10 meters either, because I've got lots of other antennas that are much better on 10, so then I do that. So if you do that, you can actually see what you're actually talking about here. Again, everyone will be different, but you can see the 240-52 with the auto transformer. It's fantastic. 80 meters, peaks on 40, a little bit down on 20, but even on 10, it's just absolutely fantastic. Not really a lot else to say. I'll put a link to this file down in the description, and you know, perhaps you want to give it a go, look at the results, query the results for yourself. There is maybe an elephant in the room, and that's the fact that if you actually hook this up to an antenna and a wire, will you actually get a match across all these bands? Well, you'll need to try that to actually find out. I know that auto transformers are quite widely used, so I've no reason to think that it won't work, but there may be some compromise. Maybe the windings may need to be spread out, etc., etc. That'll have an impact on this. How much? I don't know. You would need to then redo the back-to-back check and actually see what that was actually doing. So there we are, folks. That's just a rundown of the 3 stacks in the 2.4-inch ferrite cores. So I hope that's of some interest. I know some of you have actually eagerly been waiting for this, and I do appreciate your patience for me actually getting this video out. Please give it a go, and please feedback how you get on down in the comments. That's it for just now. We'll catch you in the next one. Bye for now.